In this video, we will discuss about centrifugation. The objectives are introduction to centrifugation, its principle, centrifuge, types, that is differential centrifugation, density gradient centrifugation, rate-zonal density gradient centrifugation, and ISOPYCNIC centrifugation. So, what is a centrifugation? Centrifugation is a technique of separating substances, and this involves the application of centrifugal force. So, centrifugation is a technique of separating substances, and this involves the application of centrifugal force. And this separation is based on the size, shape, density, and viscosity of the medium as well as the rotator speed. So, the separating of a substance is called centrifugation, and it involves the application of centrifugal force. This diagram shows the difference of centrifugation before and after centrifugation. Before the centrifugation, the particles were mixed, and after the centrifugation, they are separated into two layers. This is called centrifugation, that is, the separation of substances is called centrifugation. Next, we will discuss about the principle of centrifugation. The principle of the centrifugation is that the particles which have higher density than the solvent sinks, while the particles which have lighter density floats at the top. So, higher density will sink and the lighter density will float at the top. So, if there is a greater difference in density, then they move faster. And if there is no difference in the density, then these particles stay steady. So, what is the principle of centrifugation? Centrifugation principle is that higher density sinks while lighter density floats. So, earlier we discussed what is centrifugation, and now we will discuss what is centrifuge. Centrifuge is an equipment, and this equipment puts the object in rotation. This rotation is done around a fixed axis. So, around a fixed axis, a continuous rotation is given, and a perpendicular force is applied around the spin. So, when it spins, a perpendicular force is applied to them, and this centrifuge works in the sedimentation principle, that is, the denser substances move outward the radial direction, while the less dense move towards the center. So, what does the denser substances do? It moves out in the radial direction, and the less dense move towards the center. And this is the basic principle of a centrifuge. It works in a sedimentation principle, and the denser substances move outward in the radial direction, while the less dense move towards the center. So, this diagram explains the working of a centrifuge. The objects are moved in a circular direction. So, in a circular direction, the objects move, and this movement is around the axis. So, around the axis, the objects are made to move. When an object moves, a perpendicular action is applied on the object. So, when an object is here, a perpendicular force is applied on them. This force is the centripetal force, and this is the working of a centrifuge. So, in a laboratory centrifuge, the denser particles settle at the bottom, while the low density substances rise at the top. So, due to the radial acceleration, the denser particles settle at the bottom of the tube, while the low density substances rise at the top. So, at the bottom we see the sediment, and above it is the low density substances. This diagram shows that after a centrifugation, we obtain two parts, that is a sediment and a supernatant. The sediment has more density than the supernatant, so the sediments settle at the bottom, while the supernatant is seen above the sediment. So higher density moves to the bottom and lower density is seen above it. This is a diagrammatic representation of a centrifuge. The centrifuge tubes are inserted and they are moved in a rotational direction, and after which they are separated based on the density. That is, higher density settle at the bottom and lower density floats at the top. So there are different types of centrifuge. First is differential pelleting, also known as differential centrifugation. Second is density gradient centrifugation. Third is rate-zonal density gradient centrifugation. Fourth is ISOPYCNIC centrifugation. Next, we will discuss about differential centrifugation. Differential centrifugation is the most common type of centrifugation. First, a tissue is taken. This tissue can be a liver tissue, for example. This is homogenized at 32 degrees Celsius in a sucrose solution that contains buffer. So a tissue is taken, it is homogenized at a temperature of 32 degrees Celsius in a sucrose solution, and it also contains a buffer in that. These homogenate is then centrifuged. It is rotated at a constant centrifugal force and a constant temperature. So the homogenate, that is the liver tissue, or homogenized at 32 degrees Celsius in sucrose solution, is then centrifuged at a constant centrifugal force and a constant temperature. After doing it, we get a sediment, that is, we call it as a pellet, which settles at the bottom of the centrifuge. So a sediment is obtained as well as a supernatant is obtained. This diagram shows about the differential centrifugation. First, we have a homogenate. This is subjected to the first centrifugation and we get a pellet as well as a supernatant. The supernatant is again centrifuged and we also get a pellet as well as a supernatant. The supernatant is again subjected to other round of centrifugation. Here too we get a pellet as well as a supernatant. The supernatant is again collected and obtained a pellet. And this is how the separation of a homogeneous cell is obtained. So next we will discuss about the density gradient centrifugation. This is commonly used to purify viruses, ribosomes and molecules such as DNA. These samples are placed above a preformed gradient, usually a sucrose. So the sample is placed above the sucrose gradient, and these particles in the sample travel through the gradient until a point is reached when the density of the particles of the sample matches the density of the sucrose. So when these both density matches, the separation occurs. The fraction is then removed and analyzed. This diagram shows how a density gradient centrifugation works. That is, a blood sample is being centrifuged. A blood sample is poured above a ficol. Ficol is a preformed gradient used for the separation of the blood sample. The blood sample is being separated into RBC, neutrophils, WBC, plasmas, etc. Next is the Rate-Zonal density gradient centrifugation. This is also known as bank centrifugation or gradient centrifugation, and this is based on the concept of sedimentation coefficient. Here too there is a density gradient. A density gradient here is a sucrose, and this density gradient is present at the bottom, and sample of the protein is placed top to the density gradient. These particles, that is, the sample particles, travel to the density gradient and zones are created. These are created depending on sedimentation rate. These protein sediments are separated and collected through a hole at the bottom of the tube. This diagram shows about the rate-zonal centrifugation, that is, a centrifugation is done based on the size. So next, we will discuss about the ISOPYCNIC centrifugation. This centrifugation is also based on density gradient. That is, a biological sample and cesium chloride is uniformly distributed in a centrifugation tube. So, a biological sample and cesium chloride is uniformly distributed and allowed to centrifuge. When a centrifugal force is applied, these cesium salts redistribute and forms a density gradient from top to bottom. So, a density gradient is created by a cesium salt from top to bottom. This separation of particles is based on density, and hence it is a true equilibrium procedure since a buoyant density is used and not velocity. This diagram shows the isopycnic density separation. That is, this separation is done based on the density difference. That is, when a sample is mixed with cesium chloride and allowed to centrifugate, these cesium chloride act as density gradient from top to bottom, and hence this separation is based on density. This diagram shows the difference between rate-zonal centrifugation and isopycnic centrifugation. These samples are loaded above a density gradient. After a rate-zonal centrifugation, a shallow gradient is obtained. That is, this centrifugation occurs purely based on the size, whereas the isopycnic centrifugation occurs by a steep gradient. That is, this centrifugation is based on density. Now, let us summarize the different types of centrifugations. A is differential centrifugation. A cell homogenate is obtained. This cell homogenate undergoes a low-speed centrifugation. After a low-speed centrifugation is done, we obtain a pellet as well as a suspension. This suspension undergoes the next round of centrifugation, that is, medium-speed centrifugation. Here, too, we obtain a pellet as well as a suspension. The suspension undergoes the next centrifugation, high-speed centrifugation. Here too we obtain the pellet as well as the suspension. This suspension undergoes a centrifugation, very high-speed centrifugation, and obtain the pellet. Such a centrifugation in which a pellet and a suspension is formed is differential centrifugation. Next is B. B is rate-zonal centrifugation. It is a centrifugation in which a sample is loaded above a density gradient. This is subjected to centrifugation, and this centrifugation is based on the size. The first sediment is the faster one, and the slope is obtained second. Next is isopycnic centrifugation. In this centrifugation, it is based on density. For more such videos, do subscribe to our channel. And if you like the video, please like the button and comment as well as share with your friends.